Let me finish up with one more behavioral story. And this is perhaps, in a sense, the most famous and least talked about study in behavior genetics. This was carried out in the late 60s, or the study was started in the late 60s by Dan Friedman and his then wife. And he says there, the first study was conceived when my wife, who is Chinese, and I, in the course of learning about each other and our respective families, began to suspect that some character differences might well be related to differences in genetic backgrounds. Boy, you couldn't say that anymore. Says these notions were already near the surface as a result of my doctoral thesis finished some years before. I had worked with different breeds of dogs, and I had been struck by how predictable was the behavior of each breed. A breed of dog is a construct zoologically and genetically equivalent to a race of man. To look at us, my wife and I were clearly of two different breeds. Were some of our behavioral differences determined by breed? As I said, this is done in more innocent days. Then he talks about his doctoral work on dogs, the fact that, as he says, little beagles were irrepressibly friendly from the moment they could detect me, whereas Shetland sheepdogs were most sensitive to a loud noise or the slightest punishment, and wire-haired terriers were so tough and aggressive, even as clumsy 3-week-olds, that I had to wear gloves in playing with them. Okay. So he thought, okay, we might be able to get at comparable pre-cultural differences in humans by watching newborns and very young infants of different ethnic equals racial backgrounds. And he said, so then in collaboration with a well-known Harvard pediatrician, Barry Brazelton, they developed a kind of a test that they could apply to newborns. I won't describe that. It says, now armed with our baby test, my wife Nina and I went into San Francisco to the hospital where our first child was born. A substantial number of Chinese babies are born there, and we were able to examine both Chinese and Caucasian newborns. And then, bottom line results. It was almost immediately clear that Chinese and Caucasian babies were indeed like two different breeds. Caucasian babies started to cry more easily, and once they started, they were more difficult to console. Chinese babies adapted to almost any position in which they were placed. For example, when placed face down in their cribs, they tended to keep their faces buried in the sheets rather than immediately turning to one side, as did the Caucasians. In a similar maneuver called the defense reaction by neurologists, we briefly pressed the baby's nose with a cloth, forcing him to breathe with his mouth. Most Caucasian and black babies fight this maneuver by immediately turning away or swiping at the cloth with the hands, and this is reported in Western pediatric textbooks as the normal expected response. However, not so the average Chinese baby in our study. He simply lay on his back, breathing from his mouth, quote, accepting, unquote, the cloth without a fight. And he says, I must say that this finding is most impressive on film, and audiences have been awed by the intergroup differences. Other more subtle differences are equally important. For example, both Chinese and Caucasian infants would start to cry at about the same point in the examination, especially when they were undressed, but the Chinese would stop sooner. Furthermore, if picked up and cuddled, the Chinese babies would stop crying immediately as if a light switch had been flipped, whereas the crying of the Caucasian babies only gradually subsided. In another item, we repeatedly shone a light in the baby's eyes and counted the number of blinks until he adapted and no longer blinked. It should now not be surprising that the Caucasian babies continued to blink long after the Chinese babies had stopped. And this sort of work was repeated by some of his students in American Indian populations with very similar results. Now I've mentioned morphological variation, genetic variation directly, and this couple of examples of behavioral variation. My point here, okay, is that variation is the norm. The natural selection, variation is the fuel for natural selection. And remember, this is functionally significant variation. We're not talking about junk DNA here. We're talking about functionally significant variation is the fuel for selection. If you are an organism that has evolved, which is to say if you are an organism, then in fact you are going to have a great deal of functionally relevant genetic variation present. Now, what bothers people, okay, bothers some people, bothers most people, certainly bothers people at the governmental levels and voting and so forth, is what do we do about it? Or more fairly, what cognizance do we take of genetically based variation in human populations, both within population, between sex, and between populations? Do we take any concern with it at all? And there's a great fear on the part of many people that if you demonstrate that functionally significant genetically based variation is present, this could then serve as a justification for differential treatment of individuals based on that variation, and in particular, differential allocation of rights and opportunities based on this genetically based variation. Now, it is true that human beings have a very sorry history in this realm. We certainly are not very good at separating out the notion of right and the notion of equality. Okay. We seem to think that equality of rights ought to be dependent on some sort of underlying equality, and that if you demonstrated an underlying inequality, that somehow or another would justify a differential allocation of rights. And then as a concomitant of this, we have this notion that somehow or another equality of opportunity, which is really the best that a society can do, can only be measured in terms of an outcome of results. In other words, if you have inequality of performance at the individual or group level, that for an increasing number of people, this is implicit prima facie evidence of an inequality of opportunity that needs to be dealt with at the societal level. In other words, if it doesn't come out the same with respect to individuals, and in particular it doesn't come out the same with respect to groups, then there is something wrong. That somehow or another, there's something wrong here, and we then are obligated to go out there and try to fix it. But what if there isn't anything wrong? What, in fact, if you have a society that is, in fact, doing as good a job as a society can of allocating opportunities? And what will you expect? What would one expect to find? Well, this is one of those things, as Bill Wright mentioned, like death. Death is a very traumatic experience. Okay? Not for the guy who died, that's it. But it's pretty traumatic for everybody else. Immortality would be great. Maybe. Okay? But immortality is incompatible with the evolutionary process. So it's something that we have to come to grips with. As I would point out to my students, if a problem doesn't have a solution, it's not a problem. So death is not a problem because it doesn't have a solution. It's part of life. By the same token, functionally significant at substantial levels genetic variability in important factors is a part of life. It's not something that we can do anything about. What we need is, first, a recognition of this. Second, some sort of commitment to doing the best we can with respect to equality of opportunity. And then living with the results. Because I don't know how we can do as a species any better. Increasing opportunity, equalizing opportunity among individuals and groups is not only a moral and ethical position, but it is in fact the best way to go. The more people you have involved, the better off you are. Okay? But by the same token, if in fact you go for an emphasis on equality of results, what you necessarily are doing is reducing opportunity. Because the only way you're going to get an equality of results is to lower the results. So for example, males are on the average taller than females. And this is certainly a genetically based feature. Nonetheless, you could change this so that males and females came out to be the same size. Right? How would you change it? No, never mind about cutting your feet off. What? Starve them. Starve males. Well, you wouldn't have to feed them what we fed them 100 years ago. Okay? Then we'd have male and female statures the same. But we would do this only by reducing male stature, not by increasing female stature. What we do, we can optimize opportunity so as to allow full development of genetic potential, and that's the best we can do. Okay. So we can if we can reasonably call it optimization, but anyway, we can change the diet, and we have changed the diet over the past 100 years or so, such that we have gotten very significant increases in stature, so that the average Dutch male now is 6 feet tall. 2 meters. No, 1.83 meters, all right? Now, presumably there's some limit here. And we're not going to get an average of 7 feet. By the same token, we're not going to get an average female stature of 6 feet. But the thing in all of this is that the point here is that you can level down. Okay, you can make everybody come out the same by pushing the ones on top down, but you can't level up. You can't have everyone doing the same as the best. By leveling down, you get rid of the best. That is suicidal for a society. But we won't come, as I said, we won't come to productive grips with the problems implicit in this area unless we recognize what we're working with. And what we're working with is a product of the evolutionary process, and the evolutionary process produces and selects for variability. And I'll let it go with that.
Any questions?
Comment, question, Linda?
This is back to that formula, with the 2 and U. That formula was related to the population size. generation time. And then you made a comment about we're not selecting for shorter and shorter lifetimes and faster generations. But I didn't catch the link there. Given that eggs are formed in utero and are dormant until the next generation, isn't mu and the mutation rate going to be related to how frequently replication is happening?
Well, this was the thought at the time. Okay, that is, the geneticists were unanimous, basically, in thinking that mutations were errors in the replication process. Okay? And if that were true, then in fact you would have a dependence of mutational rates on generation length. And Allan and I were challenged on this in a paper in Science in 1971. And we looked at the situation and we tested the business of generation length by looking, for example, at tree shrews compared to other primates, and showed that in the molecules we were working with, the tree shrew version was no less changed or no more changed than the human version, even though the generation length disparity was 20-fold.
So what about bacterial changes?
Yeah, but wait, let's talk about the ones that I have data on, all right? And what we finally decided was that the mutation rate itself was genetically controlled. In other words, it's not the mutations were mistakes. The mutation rate was regulated genetically. And it was regulated genetically in terms of being set at some sort of maximal level. Because as I pointed out, if it wasn't set at a maximal level, then some other species would reach maximal levels.
Taxonomic feature, an attribute of this species.
Generally speaking, it's an attribute we're looking at birds and mammals, and generally we were seeing similar rates.
So it's an attribute of a class or something.
Apparently,
not
yeah.
Something about the site of the
Genetically mediated, or that mutation rates are genetically mediated, and that the number of mutations which get through this regulation so as to be available to natural selection is some very small fraction of the whole. Okay, so the actual raw mutation rate is, I don't know how high it is, but it is orders of magnitude greater than what comes out. And there's a lot of genetics involved in regulating what comes out. As I pointed out with the running example, with Friedman's example, what we notice, though, okay, is group variation, because as you go further and further out, and we don't notice the middle. You said that yesterday, or somebody saying yesterday, we don't see the middle. What we see is what's happening on the ends of the range of distribution, and as you get more and more differences between the means, then these are enormously amplified. Like I gave it the running example, a 1,700-fold amplification, okay, given by a 1.5 standard deviation difference in the two populations, because we're selecting very rigidly. We're selecting for the very best in the world, okay? But selecting a couple of standard deviations lower down, you're still talking about differences of 1 in 100 or 100 to 1 or something like that, and that's very visible. But that's the kind of thing we have to, somehow or another, learn to live with. When it happens in athletics, it doesn't bother people. When it happens in other realms, it seems to bother people. Yeah.
In the first part of your lecture, you mentioned in passing that the racial differences, ethnic differences were so recent that they must have been selected for.
Yes, absolutely.
You didn't get about that, but you seemed to exclude the possibility that it was simply sexual selection and that really it was something related perhaps to geographic location. Can you speak to that point?
Well, yeah. That's one of the points. There's so many points in here that one would have liked to expand upon it at appreciable length, and that's one of the important ones. the point I was trying to make with the species comparisons was to say, and I didn't say it specifically, that what's happening in people is a larger degree of a morphological differentiation than chimpanzees over an enormously shorter period of time. So we're talking 50,000 years as against 1.5 million between the two chimpanzees. And it actually, and if you just look at the skulls, this is not, you can see that this is not some sort of problem with the measurements. That is, if you look at the two chimpanzees, the one is just a slightly larger version of the other. If you look at two races of human, look at the skulls, they can get very different indeed, okay, just by visual inspection. Now, with respect to sexual selection, I know of no evidence, and I'll make that as a flat statement, I know of no evidence, okay, for sexual selection in Homo sapiens. I know of no evidence that people are cottoning onto or somehow focusing on what we see as racial differences in their marriage partner preferences or what have you. Indeed, the talk yesterday on beauty, and so Carl's talk, was in fact pushing precisely the opposite point. I mean, pushing the point that there are some generalities in terms of what one might be going for with respect to sexual selection. And what I do have is evidence that morphological change, okay, can take place that rapidly. So for example, if I compare two American Indian groups, okay, I can get differences between them, which are maybe a third or a quarter of the largest morphological distances that I find in the human species. And if we're talking in terms of crude time estimates, okay, let's say with the American Indians you might have 12,000 years to have produced those differences. All right, so give the species 4 times that, and we can get the amount of differences that we observe. And you know, in terms of the American Indian differences, I go back, that I don't know of any actual evidence, I won't even put incredible, but I don't know of any evidence to suggest that sexual selection is going on in the species.
There's plenty of assortative mating, but I don't see any evidence that racial differences map onto geographical correction.
Well, of course they do.
What are the functional, causal selection pressures that would have led to the differences that we see in morphology?
Who the hell knows?
Well, that's what I'm asking.
You know,
So you don't see any evidence for sexual selection, but you don't really see any evidence for the other selection pressures either.
I look at Neanderthals, okay? And I ask as to the differences, morphological differences between Neanderthals and existing human populations. What I find is that Neanderthals are not equally distant from all modern humans, that they are much more similar to some modern humans than to others. Okay? And the two groups that they tend to be most similar to, okay, are American Indians, in particular the ones off the coast of Southern California, and the Moriori, these guys on the Chatham Islands off New Zealand, and also the Tierra del Fuegans at the tip of South America, okay? And at least with the Tierra del Fuegans and with the Moriori, we're talking about very similar climates, apparently producing very similar facial and cranial morphologies. So, for example, there's a particular measurement which is in this area of the face, okay? It's a projection measurement. And in modern humans, the average on that measurement is typically around 23, 24 millimeters. Neanderthals are 37 or so and above. In the Moriori and in the Tierra del Fuegans, you actually get figures in the 30s. Okay, so they're way off of the rest of modern humans and in the Neanderthal direction. And with the Moriori, they've only had a few hundred years to manage this. So that what we do is we have direct evidence of substantial amounts of morphological change actually taking place in very short periods of time. Now, with as I say, with the Tierra of Fuegians and with the Chatham Islanders, one strongly suspects climatic effects here, that these are the facial morphology is somehow reacting to the climate. And one is getting very rapid change and convergent change. So I think that, the rates are very fast, but with respect to direct tests in populations of known antiquity, it looks like it's possible that we in fact can get much more rapid change than we would have credited previously.